Hi everybody, welcome to my YouTube channel Introduction to Firewall. In this course we are going to learn how the TCP table allow traffic to flow from the network we trust to the network we don't trust and back again. We are going to understand how we use a NAT, especially source net, to connect the private network to the internet, and we are going to understand the word DMZ and why we use it, and by the end of this course you will be solid understanding of the future that make you stateful firewall operator. Before beginning the course, you should be familiar with basic network functionality, including IP address and IP network, TCP operation including the TCP3 handshake, port number, basic understanding of the packet encapsulation. So we can start for the firewall introduction. What is firewall? Firewall is a network security system that monitors and controls incoming and outgoing network traffic based on the predefined security rules. A firewall is a typically established barrier between trusted internal network and untrusted external network, such as the internet. As we move into a firewall building into the Windows system, as well as there is a firewall built in the most of home routers, and then of course as we are moved to the enterprise, we have normally multiple firewalls, often and very high end equipment to protecting the various system within networks. So I have said the firewalls really are a fundamental security control device. Here is what we will cover in this module. We will cover in this module the why we need a firewall types, main the firewall capabilities, packet filtering firewalls, what is the firewall doing, what is the zones and policy, and what is the expected behavior of firewall, and also we are going to discuss the TCP state table and how it's work. Let's start off. Why do we need the firewalls? Let's start with this topic. We need a firewall to help protect us from some of nefarious activity, means malicious activity or network attacks that are happening on the internet. However, the firewall in modern security is only one piece of security system, and really what we are offered here is we are trying to avoid the threats from entering into our network, and we are also trying to detect when the threats enter into our network. Next topic is firewall types. There is a network firewall as well as a host-based firewall. So network-based firewall control the traffic coming into networks, and it also control the traffic leaving the network. And same as for the host main system. A host-based firewall control the traffic coming into the particular host, say like server system, and it also control the traffic leaving the host. So really, the firewall is designed to do the same thing but at a different levels. So now the next topic is common firewall capabilities. Now firewall capabilities, it will be depend on the specific solution selected. Now you might be aware of the OSI layer as well as TCP layer. When we are talking about the OSI 7 layer, we have a layer 4. It is a transport layer, and it's deal with the thing like TCP UDP mechanism. So when we have a firewall that's called layer 4 firewall, it's a really packet filtering firewall. That's mean that it can examine the packet header. Packet headers are used to control the details about the protocols that being sent, and of course the addressing information of source port, source and destination. So the protocol type, for example, might be ICMP. So when might be look specific or ping reply packets to either allow or deny. We can do that with the layer 4 packet filtering firewall. Of course, we could also examining the other packet header look like source, destination IP, v4 address, IPv6 address. We might also examining the source and destination port numbers, and to determine the network services that transmit is going to coming from either allow it or deny it. Now OSI is layer 7 is application layer, so it is the part of it, so to speak. It's got a more sophistication. So beside just packet filtering based on header, it can actually filter based on content with packet payload. So this is called the deep packet inspection. So we can certainly examining the packet filter like layer 4 firewall, but the payload is actual data that's being carried within the transmission, and it will contain the details like a specific HTTP request information or the actual data being transmitted. So the packet payload, so layer 7 can do what layer 4 firewall can do and much more. Next topic is the packet filtering firewall. It is the very interesting topic for the network security engineer. Knowledge of the OSI model is important when we are talking about the IT networking, and especially with the security. So that so when we say we have a layer 4 firewall, it's understood that that is a packet filtering firewall. So packet filtering firewall examining the packet header. You can think of packet headers as being a metadata for the actual data being transmitted, because the header containing the addressing information for the source and target, as well as the descriptive information about the protocol type and so on. So this would be a header like IP packet header, TCP header, UDP header, depending on the what's being transmitted. Protocol types such as the ICMP type 8 packets can be examining, and decision can be made as the whether or not traffic is allowed and denied. Now ICMP packet are echo requests. So whenever we are ping the command for the whenever we apply the ping for remote host to verify it is available or not. So we can also base packet filtering rule on source address for many types of, including the hardware address means MAC address. So built-in network interface, the IPv4 address, IPv6 address, as well as the port address. Now now where the MAC address identifies the network interface can't be changed. The IPv4 and IPv6 addresses are software-based address, so which identify the software, and port address is identify the service on the host. So when we say that about the MAC address can't be changed, there are always tools that allow to forge those type of things, but generally speaking, MAC address is fixed. We have the same type of address available as the destination address. Means MAC address is available for source address as well as the destination address. And remember, for example, if we are talking about the IP header, we have a source address as well as the destination IP address. All aspect of the packet can be forged, not just the MAC address, but source address, the payloads, or the data part of the packet, and so on. So we always have to take with this grain of salt. Inbound and outbound traffic comes through a specific interface, and when we built our packet filtering rule set, we can we can take a look at the where the network is origin from. Did it come into the firewall, or we are talking about the traffic going out, and rules can be applied accordingly. So this subject Means this topic is very important for the as the firewalls perspective, because it's contained all about the headers, TCP, UDP, protocol type, source address, destination address. Remember, the entire packets are easily forged inbound, outbound through a specific network. These are the very important topic for the packet filtering. So all the packet filtering depend on this object. Next topic is the packet filtering firewall types. This is the most interesting topic for a network security engineer, and it's most asking question during the interview for network security engineer. What is the stateless firewall, or what is the stateful firewall, and what is the difference between stateless firewall and stateful firewall? So let's we have talk about the stateless firewall. Stateless packet filtering firewall means that each packet is treated as an independent communication connection. So therefore, stateless means that the firewall is unaware of the established session. Now, established session goes through the handshake process, such as the TCP three-way handshake, and then after that we have a session transmission with that session. But the stateless firewall does not understand that it can look at the session and allow other subsequent traffic to be the part of that session and to be allowed in. It treats every packet individually. Now let's talk about the stateful firewall. Stateful firewall is the opposite, because it's aware of the established sessions, such as those established through the TCP way handshake. So because of this, then the stateful packet filtering firewall would be able to look and let's say it incoming packet going through the firewall and examining its current state, means on which time TCP session was open, closed and synchronized. Now we have already gone through established session between host, and yet we are receiving another session to set up and establish its session from the same system. Then our firewall will capture that and determine whether or not that's suspicious. So in stateful firewall is the aware of the established connection, so we can implement the IPsec means IP security functions such as the tunnel and decap encryption. And one point is in a stateless firewall known as the access control list, means you have to allow or deny for the every packet because it's every packet is treated as independently. So this is the main difference between the stateless firewall and stateful firewall. Next topic is the threat avoidance and detection system. The firewall is a single component of this. It's a very important component. That's what we are going to focus on this course. Another component might be to help deal with security in our network. For example, AAA and ID management. Now, AAA is not an American Automobile Association. Here is the authentication, authorization and accounting. Meaning, we are going to create a user. We are going to give those users ID, privileges, and then we are going to record what those users do, and when they do it on our network. This will give us the opportunity to validate authorized user and deny access to unauthorized user. Another component is intrusion detection system or intrusion prevention system. So now IDS or IPS is going to compare each packet of to database of malicious traffic. If the packet going through the IDS or IPS system match rules of malicious traffic or match of signature of malicious traffic, an alert will be sent out to administrator and saying, hey, this is the malicious attack on your network right now. Modern firewall are actually combining the IDS or IPS into the firewall. So we are going to talk about the in detail in the last module of this course. Another component we can add here is the URL filtering. URL filtering are the great for the preventing our internal users from accessing website like pornography or any malicious websites. If we are a business, we are doing the business that is working on customer population, so chance we are going to stop the user from being able to access pornography. But in deeper sense, what we can do, we can use that URL filtering from preventing user to accessing website that have a non-malicious content. Additionally, we can stop people from browsing to torrent site with intents of downloading of movies or software which is illegal. So URL filter have a lot of capability of limiting what website our users can be actually browse. Now our next important component is antivirus scanner. So some antivirus feature are also inbuilt in our firewall, but we have to also deploy antivirus in system, host or server as well, as because virus scanning is always important component for a network. We can't always rely on the virus scanner to stop viruses. Virus scanner are medical attempt to prevent viruses. My experience with them is they do much better job of alerting you that there is a virus, and you can detect in your workstation. And last one, most important component is logging. So we can take logging of all of our device, or AAA device, or our firewall, or our IDS, or our URL filter, virus scanner. We can consolidate all those logs into one system and add them into system that we can get like a same security, same system will actually analyze those logs for us and provide us some information about what actually is happening on our network from security's perspective. For those of these codes, let's just focus on the firewall. Now let's discuss about the next topic. So what is the firewall doing? In order to talk with this topic, we need to set up some vocabulary to talk about the zones. For example, firewall divides a network into two zones. The basic idea is here we have untrusted outside public network. This is, for example, it's the internet, and we have a trusted inside local network zone, which would be inside of our home or inside of our business. So here is the two groups, trusted or untrusted. So we use that to make decision how traffic can flow through one zone to another zone, one trusted network to another trusted network, one private network to one public network. Here we have an example. User open his browser and user send HTTP request out to the untrusted network. The untrusted network replies, and what we want is we want our firewall to allow that traffic. We want our firewall to allow user to browse out to Google, and then have a Google send back the website through firewall. What we don't want have happen is have some request, any other request coming from untrusted network to public net or public network to come into firewall. We don't want to allow them. We want that deny. So any other request coming from the untrusted public network, we want deny. The only traffic we won't allow is here the traffic that user request from Google or some other website and allow the back into the firewall. So if we want a user to be able to serve the web or build the TCP session with the device on the internet, but we don't want any device from public network building a TCP session with the users. This is only one half of what we want our firewall to do through, because in the case we want system so that the public internet can't access our internal stuff or any internal system, but our internal user can access the internet. We have another example. If we have set up a website in our trusted local network behind the firewall, and that website is accessible from the untrusted network, so if any users from untrusted networks able to make HTTP request or website request to our server, we have to allow that request in firewall, and also they will get the response from our web server. So in this case, we actually want a traffic from untrusted public network to get into our trusted network, so that a user can access our website, and if any other user or same user is trying to access non-HTTP request to our server to access our network, so by default non-HTTP request should be blocked when it's come from the untrusted network to trusted networks. Here is the only HTTP request which is coming from the untrusted network to trusted network. If any other non-HTTP request is coming from the public network or untrusted network, so it's by default blocked by firewall. So this is our second example. In this example, we are allowing request HTTP request only from untrusted network to trusted network. Let's talk about our next topic, security zone. Security zone in a firewall line identifies the trustworthiness of a network. All firewall vendors are going to call this security zone something slightly different. For the trusted network side, we often call the inside or internal network or LAN network or LAN zone. For untrusted network, we typically call this network outside or public network or internet or WAN zone. Now we can have a more than just two network here, trusted and untrusted. We actually have these other networks that follow some placed in between, and these are called DMZ network, demilitarized zone network, or perimeter network, which oftenly completely trusted or not completely untrusted. They are some placed in middle. There are some specific module in this course, so that will talk about the DMZ networks and why we use them. About the security policy. Security zone allow us then to develop a security policy. For example, first we have to create a zone, and then we can apply on security policy on that zone. So it's allow us then create some rule to determine how traffic should be flow from one zone to another zone. So we are going to identify the flow of traffic either from trusted to untrusted or untrusted to trusted. We are going to take the traffic flow and we are going to apply permit or deny rules for to the flow, so that the traffic that we want allow through our device flow through the device, and the traffic that we don't want to flow through the device gets blocked. We can apply other rules to traffic as well, as like network address translation, which we will talk about in second module of this course. Also difficulty for the FTP traffic or any at the 3 traffic. We have we have to apply some rules for that. So we talk about how we apply those rules in separate module we are going to discuss. So right now we have security zones, and we use those security zones to apply a security policy. Now our topic is desired firewall behavior. So here is we have one example of we have one PC firewall and one web server. So on the left I have a PC. This is going to be the part of our trusted zone, and on the right side we have a outside web server. In this is going to be our untrusted zone. So we have to forward a traffic from trusted to untrusted. So if I am a user on inside PC and I want to browse to the outside web server, I want to send a TCP SYN message to that server, and I want the server to be able to reply to me, and I want it to be able to send the TCP acknowledgement so we can complete the three-way handshake, and then we can transfer the any information we want. That's what I'm looking for it. So I need that firewall to allow me to send out SYN message and receive SYN acknowledgement back, and then be able to send a TCP acknowledgement out again, and then able to transfer the data over the connection. So what I don't want happen is to have my outside web server send a TCP SYN message into firewall. I want that message to disappear. I want the firewall block that message, because what I don't want is, I don't want outside device building a TCP session from the outside to inside unless I explicitly allow them. So however we are going to accomplish with this TCP state table, this is where the concept of stateful firewall comes into play. The TCP state table we are going to do here is send a message to our to outside the web server from our inside trusted zone through firewall. So in this case, we are going to record the TCP state and how it's create a session, and how it record the source IP and port, destination IP and port. Then it's also record the TCP state. Here is one example we are going to discuss. In this case, if I want to browse the outside web server, my TCP SYN request message take it brief it stop at firewall, and it record the source IP, destination IP and port, and the current state. The current state is that SYN message has been sent. Once we record that state, we have sent that to the outside web server, and the outside web server can be respond with it within a CNAC. So when the CNAC comes in from the untrusted zone, by default it's going to block all traffic origin from the outside. However, we want to get this TCP CNAC back into our inside network. So we are going to do here is we are going to take that CNAC coming back from outside web server, and we are going to compare it with our TCP state table, and we are expecting this message come back too. Now of course the source and port and destination IP and port, we are going to be flip-flop in our chart to return traffic, but it's all the some basic information. Since last TCP stage record in the table was SYN sent. So we are going to be looking for and allowing CNAC message back from web server. The IP is 172.25.10.100 and on port 80 coming to my inside PC's workstation. Since that's the case, we will then change the state of our TCP in the table and forward that message on the inside PC, and then allow the inside PC then to send a TCP acknowledgement. When the acknowledgement flow through the firewall, here once again it's replace the TCP state with previously it was CNAT, now it's established, and we forward that message on outside network or web server. Now since the state is established, any conversation happening between inside PC and outside web server on the IP address and port listed in our table, all the traffic will be allowed. If the outside web server is trying to send the same message from a untrusted zone into firewall, it's going to be denied. There is no rule that say allow same message in here. As a matter of fact, we are explicitly denying all the TCP SYN message. The only TCP SYN message that can flow through a firewall are the ones that flow from trusted zone to untrusted zone, not on the other way around. So this is going to be denied and thrown away. That's how we are using a TCP state table to allow an inside user to browse to internet and get response, but prevent folks out on the internet in our untrusted zone from browsing into our network and accessing internal resources. So we are using a state table to permit or deny traffic based on where the traffic was origin. So this is the example we have discussing from related one PC is accessing the internet or web server from untrusted zone. So in this topic we have discussed about the TCP state table, how it's created and how it's work. We have already discussed about the firewall behavior, and we have already discussed about the firewall how it's operate. By default, firewall always drop a traffic between two different zones. Here we'll talk about the permitted traffic or denied traffic. Permitted traffic, for example, we have always allowed traffic for trusted to untrusted and return. And if we have explicitly allowed for a particular untrusted user to trusted, so it's also in a permitted traffic. And denied traffic, by default, untrusted to trusted traffic always be denied in the firewall. Next chapter we are going to discuss related the NAT network address translation. What is NAT, dynamic NAT, static NAT, port address translation, how it's work in our next module. What's up everybody? Our next module is network address translation, NAT. In this video we are going to describe the network address translation. We are going to examine the how dynamic net works, how static net works, and how port address translation works. Now what is NAT? NAT is a network address translation. It is a technique that helps minimize public address uses. As per the IANA rules, 3 private IP address ranges that cannot be routed on the internet, and they are used for only internal purposes. So we can also say that the NAT is an agent between internet and local network. It also provides security. It's hiding our internal network behind one or more public IP address. NAT is only not available on routers. It is also available on firewalls and load balancer. Now we are going to discuss about the types of NAT technology. First one is a dynamic NAT, second one is static NAT, and third one is a port address translation, PAT, also known as a dynamic net. So first we are discussing dynamic net. Dynamic net can be defined as a mapping of private IP address to a public IP address from a group of public IP address called as a net pool. So here is a multiple private IP address and multiple public IP address. So it's a randomly select mapping between the public IP address and private IP address. It's also called as a dynamic net. Now we are going to discuss about the static net. Static net means one-to-one mapping of private IP address to public IP address. Static net is useful when network device are inside a private network and needs to accessible from the internet. It's called we are used in port forwarding. Now our last one technology is PAT, port address translation. Port address translation is another type of dynamic net which can map multiple private IP address to a single public IP address by using a technology known as a port address translation. Before we understand how nets work, we have to understand the IP packet header and TCP header, because it's the main component for the net technology. NAT is clearly manipulating the packet header. It is clearly manipulating the source and destination address. NAT is designed to manipulate either one source or destination or both. Now regarding the TCP segment header, it's when we are talking about the port address translation, we need to bring in the TCP segment here and see that we are actually manipulating the source and destination port numbers as well in this technology. Now relevant for NAT. What's relevant for NAT here is the source IP address, destination IP address of the packet, and the source and destination port of the segment. When we put this together, we call them sockets. So we have a source address, source port number, and destination IP address and destination port number. So the socket is what we are going to be recording and manipulating and working with when we are doing a NAT. So it's a useful component for the NAT. So source address, destination, source port, destination port. In order to understand how NATs will work, we need to understand how IP network address translation terminology. Here is the local network, here is the public network, and how we can identify our manipulating packet and ports using some vocabulary like inside local, outside local, inside global, outside global. So we need to understand the difference between local and global areas of our network. The idea here with NAT is that we need to identify a local area of packet to exit and a global area for the packet to exit. And what we will do is we will record the information of the packet when it's in local network. We will manipulate the packet header and then send it to the global network to get sent out, and then we will reserve the process when it's come back. So local and global are identifying which side of NAT device that we are talking about. This will be proved useful for us because in order to apply NAT when we are doing a dynamic NAT, we need really a good understanding of local versus global. So this is the I have captured one image from the Google, so you can see that and identify that. In this video we will going to discuss how NAT will be take action when its traffic move from local network to global network, and we have also discussed regarding the local network versus global network, and we have also discussed regarding the how it will be NAT will be manipulating the IP header and TCP header to take action for a NAT technology. So here is the one example. We have one system in local area network. We have mentioned that source IP 10.0.0.10, and it's using a random port trying to communicate with the global server on port 80.203.113.110 IP address. So now it will create for example, we have show that it's create a net table. For example, inside local, outside local, inside global, and outside global. For inside local, it's our local system IP address and port. Outside local means which we are trying to access IP address and ports. Inside global means our WAN interface of firewall, or our public IP of ISP, which we have terminated on the firewall. So it's we have mentioned that IP and ports. And outside global, same as the IP address and port. This is the created table during the local to global traffic. Now we are going to discuss regarding the what happened when it's come from the global to local. Here is we have seen that it's manipulating the source IP address to take a action. So when traffic is passing from local to global, it's manipulating the source IP address. You can see that. Now we are going to discuss what happens if traffic will be written from global to local. Here is the example. With the same example we are going to discuss here. Here is the inside local, outside local, inside global, and outside global. Okay. Now for inside local, same IP address, outside local, same IP address and port, inside global, same IP address and port, and outside global, same IP address and port, which we have during the created NAT table. Now we can see that here is the we can manipulating the destination IP address. You can see that here is the source IP address is from global IP which we are trying to access. So source IP and destination IP means source IP is trying to communicate with the WAN interface which we have terminated on firewall. So in this scenario you can see that the return traffic will be manipulating the destination IP. So we can identify that during the local to global it's manipulating the source IP, and it during the return traffic it's manipulating the destination IP. So here is the one example for better understanding. We have already discussed regarding the static net, but here is the one example. Static net means it's a one-to-one mapping between two addresses. It's a mapping one IP address, private IP address to public IP address, and public IP address to private IP address. And here is the one example how it's work. You can see that outgoing connection, incoming connection. When it's going to the outgoing connection, it translates the source IP and source port. But when it's incoming connection, it translates the destination IP address and destination port. So it's very useful to understand how it's work. In this section, we are going to discuss related port address translation, dynamic PET, and dynamic NAT with overloaded. So we discussed in previous section. Port address translation is the another type of dynamic NAT which can map a multiple private IP address to single public IP address by using a technology known as a port address translation. Here we can see the example, and what happened when client from inside network communicate to host in the internet. The firewall changes the source port. It doesn't matter it's a TCP or UDP. So it's change the source port with another port. This port mapping are kept in table. When the firewall receives from the internet, it will be refer the SAM table, which kept the port mapping and forward the packet to the original sender. We can discuss with this example. In our local area network, we have a two system which is trying to access a global server at the same time, and we have only one IP address, public IP address. So what happened and how it's create a NAT table. So in NAT table, inside local, outside local, inside global, outside global. Inside local means our IP address systems and its ports. Outside global means its IP address and its port. Inside global means our WAN IP and WAN IP of our firewall or interface IP of our firewall. So in inside global we have a one IP address, so we have mentioned that IP address, but we are changing the source port because we have only one IP address. So in a port address translation means it's changing the source port. Okay, so you can understand now. This is our WAN IP address and this is the port. This is also our WAN IP address, and it's a change with another port because it's a create a session at the same time, and it's outside global IP address and ports. Let's talk about the when traffic will be written from global network to local network. What happened? It's used the same NAT table which was created during the traffic flow from local to global. In this scenario, we can see that it source IP address and source port, destination IP address and destination port. And what happened at local side, it's also use the same source IP and source port, and destination IP and destination port. So in this scenario we can see that it's we have changed the only source port. Means clients, when the clients are trying to communicate with the global server using the same IP address at the same time, so it's use the same inside the global IP, but it's changed the only source port. In this video we are going to describe the NAT terms, all the types of NAT, means source NAT, source and destination NAT, and destination NAT. We are going to describe here with the example. Here is the example of source NAT. Source NAT is used to translate the source address of outbound packet that leaves a firewall's interface. It doesn't matter if it is the internal or external traffic. One common use of source NAT is the translation of private IP address into a smaller number or just a one public IP address. This is something the most network use both in enterprise environment as well as the home environment. Let's discuss related destination NAT, DNAT. This is the translation of destination address of inbound packet that enter a firewall's interface and the translate the destination address before sending it out on the aggression interface. The firewall knows where to send the packet based on the translation address that has been configured. In the destination NAT rule, you define the original destination IP address and possibly destination port as well as the translation address that packet will be routed. The destination NAT can be on that the destination NAT can only be used in inbound traffic. That's the entire firewall's interface. Here is an example of two destination operating as per the port base we are going to discuss. The most common use of destination NAT is when you have a scenario on your internal network that you want to allow access from the internet. As per the diagram, client can access both web server and FTP server by using the IP address 10.10.10.200, and the address will be translated to the internal address depending on which TCP port that user uses in the request. Now we are going to discuss regarding the what happened with the return traffic during the destination NAT and source NAT, because we have only describe the traffic flow in a one direction, but it's happen when a host reply back. When traffic is first passed through the firewall, it will create a session. This session will be created to stay open as long as the communicating application are actively exchange the packet. The firewall will monitor traffic traveling back and forth. This is called the stateful packet inspection. So a session record contains information such as the source and destination IP address and ports and current sequence number of the last packet. A stateful firewall store all the active and permitted session in session table. This sessions table is stored in RAM, and each record also contains the timeout value. If no communication occur within the timeout period, this session will be closed and removed from the table. But if the firewall also receives the FIN or reset packet, the connection will be closed. Stateful packet inspection also enable the firewall to check each incoming packet and confirm that it actually belongs to a valid session, and this increases the security since the traffic is passing through is expected traffic. To use a destination net, an example, we have a client on the internet that is trying to access a server on the internal network. When the SYN request has been received by the firewall, it will first create a session so it can track the state of the session along with the IP address, port number and sequence number. After that, it will be translate the destination address to internal IP address of the server. When the server reply backs to the client with a SYN, the packet will pass through the firewall and it will recognize that the traffic belongs to a valid session. If FIN packet has been received, it would be a drop as it wouldn't a valid packet or three-way handshake has not yet completed. So with the server reply, the firewall translates the server's internal IP address to relevant external IP address and forward it to the client. The client will have a no knowledge of server internal IP address. The whole scenario we have described in this session. What's up everybody? In this section we are going to discuss related DMZ. DMZ means what? DMZ means a demilitarized zone. DMZ is essentially part of network security for both individual user as well as a large organization. They can provide an extra layer of security to an organization's local area network. The ultimate goal of DMZ is to allow access to resource from untrusted network while keeping the private network secure. Resource commonly placed in the DMZ network like web server, mail server, FTP server, VoIP server. So main purpose of DMZ is to protect from the inside network as well as the outside network. So host in DMZ can communicate with the both internal and external network, but communicate with the internal network host is tightly restricted. And then there are two possibly ways to construct the network with a DMZ. The two major methods are using a single firewall or a dual firewall, means using a two firewall. Using a single firewall we called as a DMZ zone, and using a dual firewall, it's called a DMZ network. Let's talk about the DMZ zone. DMZ zone means using a single firewall, a modest approach to network architecture to involve a single firewall with a minimum 3 network interface. The DMZ will be placed inside of this firewall. The type of operation is as follow. The external network interface make the connection from the ISP. The internal network is connected by LAN interface, and the connection within the DMZ is handled by the third network interface. We call it as a DMZ interface. Now let's talk about the DMZ network. DMZ network we can construct using a dual firewall, means using a two firewall. The more secure approach is to use a two firewall to create a DMZ. The first firewall referred as the front-end firewall, and it's configured to only allow traffic to destined for the DMZ. The second firewall referred as the backend firewall is the only responsible for the traffic that travels from DMZ to internal network. In effectively way of further increasing the protection to use a firewall built by separate vendors, because they are less likely to have same security vulnerabilities. While more effective, this scheme can be more costly to implement across a large network. So in this video we have discussed regarding the DMZ zone or DMZ network, how we can build. Hello guys, in this module we are going to discuss next generation firewall. Let's talk about the next generation firewall. In this section we are going to cover what is the next generation firewall, application awareness and user control, and intrusion prevention system. Now what is next generation firewalls? A next generation firewall is a network security device that provides the capability beyond the traditional and stateful firewall. While traditional firewall typically provide the stateful inspection of incoming and outgoing network traffic, but next generation firewall includes additional features like application awareness, plus URL filtering, virus scanner, intrusion prevention, and user control. And also you can include cloud delivery threat intelligence like sandboxing. The main benefit of next generation firewall is the ability to safety enable the use of internet application that empower user to be more productive while blocking a less desired application. Next generation firewall achieve this by using a deep packet inspection to identify and control application regardless of the IP port used by application. Now let's talk about the application awareness and user control. Application awareness means it's visualize the application, what applications are being used or misused in our organization. Application awareness and user control, when we are looking at the user and the user on our inside of our network is trying to access the outside of network, our application awareness here, what it can be do. It's for example of one of our engineer needs to get access of Facebook, LinkedIn or Skype or Office 365, but it's maybe not allowed to for the particular snapshot or Tumblr, because it's a more private things or more personal. Now at deeper level we can even go like into Facebook. We can actually go and restrict access within Facebook itself. So maybe we allow a user to browse a Facebook, but we don't allow them to post anything, play any games or anything sorts. Maybe we just want our user to be able to like things on Facebook but not posting things. So I'm not quite sure what the advantage of all of is, but a lot of organization will have a very respective policy like that, and this device to be a great job of implementing that. Additionally, if we have another employee in our organization, maybe he is a scientist this time, or we can give him that user to access to different things based on their needs. So maybe this user need to access a Facebook, Skype, Microsoft Office, but in order to do job they also need to connect with his LinkedIn or so we can create a policy then that that particular user to get to LinkedIn and other users not get to LinkedIn. We can do this all the through, this is the one single device which is relative new in this industry, and then if we want to block or our access to this, we can still do that. Now let's look at application awareness direction. Application awareness works in two directions. The inside user is trying to access a resource. On the outside, we have a combination of user control plus application awareness, meaning that we can identify that they are going to particular Facebook or going to Facebook and playing a game. In other direction, application awareness means that we have a user out on the internet and is trying to access our web server, and we have only allow only HTTP traffic and deny all the non-HTTP traffic. So if users are going to access our server using HTTP means through a browser, then it's accessible. But when users are trying to access using a telnet session on port 80, it would be block. Means it's a protocol awareness. Means it's allow only HTTP traffic to web server and deny any non-HTTP traffic. So here is the one example. We have a one server and user one is trying to access web server on HTTP protocol, but second user is trying to access a web server using a telnet on port 80. So its request going to be blocked. Now let's talk about the intrusion prevention, IPS and IDS. IDS and IPS, intrusion prevention system and intrusion detection system. Intrusion prevention system work by scanning all network traffic. The IPS perform real-time packet inspection, deeply inspecting every packet that travels across the network. If any malicious or suspicious packet are detected, then that TCP session will be terminated or repackaging the payload. The way intrusion prevention work is we have a stream of bits coming from our workstation and going to our firewall and out to the internet. What our IDS will do is it will take the snapshot and compare that bits going through that to a database, and if the database detects something that's not supposed to be allowed, it's going to send an alert or just drop the traffic. Here alerts means it's used during the intrusion detection system, and intrusion prevention system will be drop the traffic based on the configure rules. The other times we can just alert on it or keep logs of it. We have all kind of action we can take here, but the good piece is that we have a database of malicious activity, nefarious activity, and we compare it to the bits of flowing through our network to make sure that we don't have any malicious bit or nefarious bits in our network that shouldn't be there. Welcome everybody. In this module we are going to discuss anti-spam. Everybody knows the anti-spam feature is available in next generation firewall. So let's talk about the anti-spam feature. In this module we are going to discuss what is anti-spam, anti-spam technology. Anti-spam allows to spam detection process and detect the spam mail based on an anti-spam scanning flow. So let's discuss about what is anti-spam. Let's first understand the spam. Spam is referred to use for electronic messaging system to send unsolicited message, especially advertising message to a group of reception. Unsolicited message means the reception did not grant permission for those message to be sent. So anti-spam refer to be use of any software, hardware or process to block from entering a system. The anti-spam software used to set up protocols to determine the unsolicited and unwanted message and prevent those messages from entering to the user's inbox. So it's scanning and detect. Talk about the anti-spam technology. Gateway anti-spam provide you with a powerful tools for scanning and detecting the spam in email traffic. So based on that tools, he so it's a block unsolicited, unwanted, irrelevant, or inappropriate message from especially the commercial advertise in a mass quantity. So it's based on the rule or policy we can prevent from the enter into users inbox. So gateway anti-spam inspect all incoming email, so SMTP, POP3 and IMAP traffic before the message are delivered to the receivers in mailbox. If spam is detected and depending on the policy and rule set, emails are proceeds and delivered to the reception, reject and generate a notification on a message rejection, add or change subject or change the receiver. Now let's talk about the anti-spam allow to. First, scan an email message from spamming by protocol, namely SMTP, POP3 and IMAP. After that, monitor and proactively detect and recurrent patterns in spam mails and combat multi-format text, images, HTML, etc. and multi-language threats. Monitor mail received from the domain and IP address. Detect spam mail using RBLs. Accept and reject message based on the message size and message header. Customize protection of incoming and outgoing email message by defining the scan policy. Set a different action for SMTP and POP and IMAP spam emails. Configure action for individual email address and notify receiver about the spam message. So we can configure this type of all the features in anti-spam module in next generation firewall. Now let's understand about the detection process of anti-spam in 6 steps. First step, spammers send a massive spam attack over the internet and mails arrive at firewall. This is the first step. After that, second step, firewall anti-spam engines send a message, a pattern of characteristics to local cache. Local cache store the spam pattern of all the recent attacks. If a message pattern characteristic is found, engine perform a step 5. Let's go with the step 5. Step 5, anti-spam engine forward a message to the mail reception if it is not in a spam, else it will be reject the mail. Okay. Step 3, if matching pattern is not found in local cache, message pattern characteristic is sent to a remote spam detection center. After that, step 5, within a few milliseconds, detection center classify the message and send a reply to anti-spam engine. So if anti-spam engine forward the message to the mail reception, if it is not in spam, else it will be reject the mail. And last step is firewall store the newly classified pattern in its local cache for the future use. Now let's talk about the anti-spam module to detect the spam mail based on. So first it will check the IP reputation, and second it will check the mass distribution of pattern using RPD. RPD means recurrent pattern detection. And the last one is custom signature. If we have created the rule for any spam detection, so it's considered as a custom signature. Now let's go for the anti-spam scanning flow. So first it will check for the IP reputation. After it scan, proceed to antivirus scanning. Check the maximum size and take appropriate action, and after that it's check the spam rules, and after it's check the anti-spam header. Now let's talk about the most important feature or topic is a VPN, virtual private network. So virtual private networks, in this module we are going to learn what is VPN, what VPN features, VPN types, VPN protocols, and conclusion. Let's start with the what is VPN. So what is VPN? VPN is a virtual private network help by establishing a secure connection over an insecure network such as the internet. This is a great alternative to private WAN connection since internet access is usually cheaper and it's available pretty much everywhere. So it's between client to firewall, router to router, firewall to router, firewall to firewall. Now let's talk about the VPN feature: confidentiality, authentication, integrity, and anti-replay. First, confidentiality. Preventing anyone from reading your data. This is implementing with encryption. Now, authentication. Verifying that the firewall or remote user that is sending a VPN traffic is a legitimate device or user. And integrity. It's verifying that VPN packet wasn't changed during the transmission. Anti-replay. Preventing someone from capturing the traffic or is sending it. Trying to appear as a legitimate or user or device. VPN types. Two types of VPN: site-to-site VPN and client-to-site VPN. Remote user. So this is the most two common VPN types we are using right now. First, site-to-site VPN. So with the site-to-site VPN, we have a network device at each site. Between these two network devices, we built a VPN tunnel. Each end of the VPN tunnel with encrypted original IP packet adds a VPN header and a new IP header, and then forwards the encrypted packet to the other end of the tunnel. So this is the one type of site-to-site VPN we have discussed here. In what happened in this picture, H1 send a IP packet with a source IP 192.168.1.1 and destination is a 192.168.2.2. Now firewall encrypt the IP packet, adds a VPN header and create a new IP header with its own public address as the source and 2.2.2. as a destination. It's a WAN IP of a remote device. Now firewall 1 send a new packet to firewall 2. Okay, and firewall 2 receive the packet, check if packet is really came from firewall 1 and decrypt it and forward it to the H2. It's our host device 192.168.2.2, and at H2 receive the original IP packet. Now we are going to discuss client to site VPN, remote user. So the client to site VPN is also called as a remote user. The user install a VPN client on his or her system, laptop, smartphone, tablet, and the VPN tunnel is established between the user's device and remote network device. Here is one example. So in this picture, the user has established a VPN tunnel between its VPN client and firewall 1. So this allow the user to access a remote server. This is the client server combination. Now let's talk about the VPN protocols. PPTP, point to point tunneling protocol, L2TP, layer 2 tunneling protocol, SSL VPN, secure socket layer. It's a user HTTPS SSL, and last one is IPsec, IP protocol security. PPTP protocol, point to point tunneling protocol. It's a older one protocol. It was released around 95. It uses ZR8 tunneling and plus PPP for authentication, and encryption is done with the MPP protocol. It's use of 1723 port number. Here is we can see the image of PPTP. Now second protocol is L2TP layer 2 tunneling protocol. It's use port number 1701. So layer 2 tunneling protocol is an extension of PPTP, as the name implies. Allow us to tunnel layer 2 traffic over the layer 3 connection. L2TP can be used if you need to bridge two remote LANs together and you want a user a single subnet on both sides. L2TP it does not offer any encryption or anything, which is why we often use it together with IPsec. When we use L2TP and IPsec together, it's often referred to as a L2TP IPsec. Here is one example of L2TP. We can see the image. Most important protocol, SSL VPN, secure socket layer. It's use SSL HTTPS. On its work on port 443, or in many firewall you can customize that port. So SSL is a protocol that normally used to encrypt traffic between web browser or web server. When you serve the web using HTTP, everything is clear text. For secure connection we use a HTTPS, so we can use the same technology of for a VPNs. So one of the advantage of SSL VPN is that since it use a HTTPS, so you can use it pretty much everywhere. Most public Wi-Fi hotspot do permit the HTTPS traffic, while something might be block other traffic like IPsec. Another reason why SSL VPN is popular, so that you don't always have to use a software client. Most SSL VPN offer a portal through web browser, and you can access application. For some advanced feature, you might have a install a software client in your device. If you are using a RDP from WAN, means it in firewall you have done a port forwarding for remote access. So it's better to don't use a port forwarding rule for, and you can use a SSL VPN client. So your traffic it's encrypted and no one can attack on RDP port. So it's more secure for remote access. The last protocol of VPN is IPsec, IP protocol security. It's a most important protocol for VPN, and most useful protocol for whenever you are creating the VPN tunnel between site to site or client to site for remote user, and between two servers to authenticate or encrypt the traffic. So IPsec is a not protocol, but it's actually framework. So it's offer a confidentiality, integrity, authentication and anti-replay feature on layer 3. So it's a use a variety of protocol, and the advantage of this framework is that the protocol it use can change in the future also. So for example, currently we are using an encryption algorithm like dash 3 dash or AES, but if new algorithm is created, then IPsec might be used in the future. So in depth I will explain IPsec in my next video. But in this lesson we have learned some basic of VPNs, like VPN can use a alternative to private WAN connection and offer a secure connection over insecure medium such as the internet. VPN offer a feature such as the confidentiality, authentication, integrity and anti-replay. The most common VPN types are site-to-site VPNs and client-to-site VPNs. Some common VPN protocols are IPsec, PPTP, L2TP, SSL VPN. IPsec is a framework to provide a security on layer 3. PPTP is a older VPN protocol. It's use a PPP and GRE insecure and should not be used anymore. L2TP, a VPN protocol that's tunnel or layer 2 traffic, does not offer any encryption or anything. SSL VPN, it's a user SSL HTTPS to create a secure connection with the web browser or client. Welcome everybody. In this video we are going to discuss regarding the IPsec, IP protocol security and IPsec VPN. In this module, IPsec module, we are going to discuss what is IPsec, benefit of IPsec, IPsec mode, tunnel mode and transport mode, IPsec framework, IPsec protocols, authentication header, encapsulating payload, internet key exchange and IPsec tunnel creation. Let's start with what is set up protocol and algorithm to used to secure data. It's provide a layer 3 security. It's a combine of different components like security association, authentication header, encapsulating security payload and internet key exchange, SA, AH, ESP and IKE. Let's talk about the benefit of IPsec. So IPsec can protect our traffic with the following features like confidentiality, authentication, integrity and anti-replay. So let's start with the confidentiality. It's encrypt our data by and nobody except the sender or receiver will able to read that data. Now talk about the authentication. So the sender and receiver will authenticate each other to make sure that we are really talking with device we intend to. So authentication happening by signature or certificate. Now let's talk about the integrity. Integrity, it's a calculate the checksum or hash value of the data. So we want to make sure that nobody changes the data in our packets by calculating a hash value. The sender and receiver will able to check if changes have been made to the packet. Now anti-replay. Anti-replay, even if packet is encrypted or authenticated, an attacker could try to capture this packet and send them again. So by using a sequence number, IPsec will not transmit any duplicate packets using anti-replay features. Let's discuss IPsec key points. IPsec can ensure the confidentiality and or the authenticity of the packets. The main key points are IPsec cover two modes of transport mode and tunnel mode. Second one is security association, SA, and two types of header, ESP and AH. Let's discuss tunnel mode and transport mode. In tunnel mode, entire IP packet is encrypted and becomes the data component of a new and a larger IP packet. So frequently used in IPsec VPN. Now discuss transport mode. IPsec header is inserted into the IP packet. No new packet is created. Work well in networks where increase the packet size could be causes an issue. Frequently used for a remote access VPN. Now let's discuss IPsec framework. IPsec frameworks is the combination of IPsec protocol, encryption, authentication and defilement identifier algorithm. So in IPsec protocol you have a ESP plus AH and AH. ESP means encapsulating security payload and AH means authentication header. In encryption we have a three option, dash, 3 dash and AES. It is the encryption protocol. In authentication we have a MD5 or SHA for authentication choice, and DH we have a DH1, DH2 and DH5 for a diff element identifier to drive a share secret. To establish a IPsec tunnel, if we have to establish a IPsec tunnel, then we have to require a protocol like IKE, internet key exchange, and we have for a build IPsec tunnel we have two phases, IKE 1 phase 1 and IKE phase 2. Let's discuss with the IKE phase 1 what happened in IKE phase 1. Two peers will be negotiate about the encryption, authentication, hashing and other protocols, and establish the Internet Security Association and Key Management Protocol session. IK phase 1 is only for used for management traffic. We use this tunnel as a secure method to establish second tunnel called IK phase 2 tunnel. So IPsec tunnel for the management like keep alive. So we can see that IK phase 1 tunnel in image. It's used for to secure IK phase 2. Now IK phase 2. So once IK phase 1 is complete, we have a IK phase 2 that we can use to protect our data. This user data will be sent through IK phase 2. IK builds the tunnel for us, but it doesn't authenticate or encrypted user data. So we use other two protocols like authentication header and ESP encapsulating security payload. AH and ESP both offer authentication and integrity, but only ESP support encryption. Because of this, ESP is the most popular choice now for IPsec VPN. Both protocols support two different modes, transport mode and tunnel mode. Let's discuss with transport mode and tunnel mode. The difference between transport mode and tunnel mode. So the main difference between the two is that the transport mode will use the original IP header, while in the tunnel mode we use a new IP header. Here is the example to help to visualize this. So you can see that in PPT. Transport mode is often between two devices that we want to protect some insecure traffic. For example, telnet traffic. Tunnel mode is typically used for site-to-site VPN, where we need to encapsulate the original IP packet, since that most private IP address and cannot be routed on the internet. I will explain these two modes in details later in this module. Now let's discuss the entire process of IPsec in 5 steps. First step is initiation. Second is IK phase 1. Third one is IK phase 2. Fourth is data transfer, and fifth is termination. So let's start with the initiation. For example, when we are configuring IPsec on firewall, used to access list to tell the firewall what data need to protect. When the router or firewall receive something matches to access list, it will start the IKE process. It's also possible to manually initiate the tunnel. So it's in first step, it's determine the what or which traffic will be encrypted in the tunnel. And the second step is IK phase 1. In IK phase 1, we negotiate the security association to build the IK phase 1 tunnel. And third step is the IK phase 2. So within the IK phase 1 tunnel, we build the IK phase 2 tunnel, IPsec tunnel. And the fourth one is a data transfer. So we protect our user data by sending it through IK phase 2 tunnel. And last one is termination. When there is no user data to protect, then IPsec tunnel will be terminated after a while. IPsec protocol. So AH and or ESP are the two protocols that we are used for actually protect your user data. Both of them can be used in transport or tunnel modes. Let's walk through all the possibility options. So IPsec protocols, authentication header, EH, ESP, and you can use both. Authentication header protocol. AH offer authentication and integrity, but it does not offer any encryption. It's protect the IP packet by calculating the hash value over almost all the fields in the IP header. The fields it's exclude are the ones that can be changed in transmit. So let's start with the transport mode. Transport mode is a simple. It's just adds sorry. It just add the authentication header after the IP header. Here is the example of IP packets carry some TCP traffic. With tunnel mode, we had add a new IP header on the top of the original IP packet. So this could be useful when you are using a private IP address and you need to tunnel your traffic over the internet. It's possible with the AH, but it does not offer any encryption. Now IPsec protocol ESP. It's encrypt the IP traffic, protect the IP packet by calculating a hash value. If both AH and ESP are applied to a packet, AH follow ESP and provide all that is offered by AH, and use the IP protocol is 15. This is the IPsec protocol ESP, encapsulating security payload. IPsec protocol ESP encapsulating security payload protocol. ESP is the most popular choice of two since it's allowed to encrypt IP traffic. We can use it in transport mode or tunnel mode. Let's look at both. And transport mode, when we use the transport mode, we use the original IP header and insert the ESP header. You can see that in image, and you can see that we added ESP header in trailer. Our transport layer and payload will be encrypted. It's also offer authenticated, but unlike AH, it's not for the entire IP packets. ESP in tunnel mode. So we use a new IP header which is useful for site-to-site VPN. It's similar to transport mode, and we add a new header. The original IP header is also encrypted. Now IPsec protocol authentication header plus ESP, encapsulating security protocol. So this is one confuse for a lot of people. If it is possible to use a AH and ESP at the same time, let's check it out. First we are checking in transport mode. Here is the original IP packet header, and with the transport mode we will use the original IP header and follow by an AH and ESP header. The transport layer payload and ESP trailer will be encrypted. Because of we use AH. The entire IP packet is authenticated. Now look into we will use a new IP header. For AH or AH and ESP header, the original IP packet will be completely encrypted and everything will be authenticated thanks to AH. So, authentication header in transport mode. Here what's that look like in WireSec. You can see that the protocol authentication header and so authentication in between IP header and ICMP header. This is the capture. I took a ping between two firewalls or routers, so you can see that the authentication use of 5 fields. So next header, length, SPI, sequence, or integrity check value. So in next header, this identifies that the next protocol. Here is the example in ICMP. This is the length of authentication header. This is the security parameter index. This is the 32-bit identifier, so receiver know to which flow these packets belong to. And sequence, this is the sequence number that helps against the replay attacks. And integrity check value, this is the calculate the hash of the entire packet. The receiver also calculate the hash. When it's not the same, then you know something is wrong. So let's continue with the tunnel mode authentication header in Wireshark. So you can see that the new IP header, then AH header, and finally original IP packet that carry some ICMP traffic. One problem with the AH is that it does not play well with the NAT or PAD. So filled in the IP header like TTL, checksum are excluded by AH because it's no, this will change. The IP address and port numbers are included. If you change this with NAT, the CVV look in Wireshark related to ESP in transport mode. So you can see that the original IP packet that we are using ESP, the IP header is in a clear text, but everything else is encrypted. ESP in tunnel mode. In Wireshark we can see that the output of we captured is similar to the transport mode. We have seen that the only difference is that the new IP header you don't get to see original IP header. So the only difference is that the new IP header added in tunnel mode. Here's what it look like in Wireshark. AHP and ESP header in transport mode. So you can see that the original IP packet and the AH header and ESP header. So here is the authentication header, here is the authentication header and encapsulating payload. IK, Internet Key Exchange, is the one of the most important primary protocol for IPsec, since it establishes the security association between two peers. This is the two type of version, like IK version 1, IK version 2. IK version which was introduced around 1998 and suspended by IK version 2 in 2005. There are some difference between two versions. IK version 2 require less bandwidth than IK version 1. IK version 2 support the EPA authentication. EPA authentication means it's used for some like preset keys or digital certificate to authentication. IK version 2 has built-in support for NAT travels require when IPsec peer is behind the NAT router. So it is also used for when your IPsec peer is behind the NAT router or firewall. IK version 2 has built-in keep alive mechanism for the tunnels. So the list with advantages goes on, but let's focus on understanding the IK. As explained before, IK used two phases, IK phase 1 and IK phase 2. Let's discuss what happened at each phase, and everything I explained below applies in IK version 1. IK phase 1. The main purpose of IKE phase 1 is to establish a secure tunnel that we can use for IKE phase 2. We can break down the phase 1 in 3 simple steps. First step is negotiation. So the peer that has a traffic should be protected will initiate the IKE phase 1 negotiation. The two peers will negotiate about the following items like hashing, authentication, DH group, lifetime, and encryption. In hashing, we use hashing algorithm to verify the integrity. So we can use a MD5 or SH for this. Authentication, each pair has to prove who he is. Two commonly used for a pre-set key or digital certificate. DH group determines the strength of the key that used in key exchange process. The higher group numbers are more secure but take a longer to compute. Now let's talk lifetime. How long does the IKE phase 1 tunnel stand up? The shorter time lifetime, the more secure it is, because the rebuilding it means we also use a new keying material. Each vendor use a different type of lifetime. A common default value is 86400 seconds, means 1 day. Now let's talk about the encryption. What algorithm do we use for encryption here? Here we can use dash, 3 dash, or AES. Now step 2, DH key exchange. Once the negotiation has succeeded, the peer will know what policy to use. They will now use two DH group that they negotiated to exchange keying material. The end result will be that both peers will be share the key. Step 3, authentication. So this is the last step for two peers will authenticate each other using authentication method that they agree upon the negotiation. When the authentication is succeed, we have to complete the IKE phase 1. The end result is IKE phase 1, which is bidirectional. This means both pair can send or receive on this tunnel. The 3 steps above we can complete using two different methods: main mode and aggressive mode. Main mode is 6 messages, while aggressive mode use only 3 messages. Main mode is considered is more secure. Let's look at closer look at both ends. IKE version 1 main mode uses 6 messages. I will show you this in Wireshark. I will explain the different fields. So main mode uses 6 messages. This is the message 1. The initiator, that the peer that wants to build the tunnel, will send the first message. This is proposal for the security association. Above you can see that the initiator use the IP like 192.168.12.1 and is sending to proposal to responder IP address 192.168.12.2. IK use a UDP port 500 for this. In this output above you can see that the initiator SPI security parameter index. This is the unique value. This is the unique value for the security association. Now message 2 for main mode in IKE version 1. So when the responder receives the first message from the initiator, it will be replied this message. This message is used to inform the initiator that we agree on the attribute in the we have decided in the first message. So you can see that the responder has set its own SPI value. You can see that the initiator SPI value and responder SPI value in message 2. Message 3 in main mode for IKE version 1. So once we our peers agree on security association to use, the initiator will start the DH key exchange. So in the output you can see the payload for the key exchange. Message 4, main mode, IK version 1. The responder will send his or her DH nuns to initiator. Our two pair device can calculate the DH shared key in message 4. Message 5 and message 6 in main mode for IK version 1. The last two messages are encrypted, so we can't see this anymore. These two are used for the identification and authentication for each pair. The initiator start. So this is the identification related messages, or these messages are encrypted. IK phase 1 aggressive mode, message 1. IK1 aggressive mode only requires the 3 messages to establish the security association. It's quicker than the main mode. It's add all the information required for the DS exchange in first message. Main mode is considered more secure since identification is encrypted. And aggressive mode does this in clear text. Let's take look at the different messages. The first message from the initiator 192.168.12.1 and to the responder 192.168.12.2. You can see that the transform payload with the security association attributes, DH nuns, and identification in clear text in the single message. Here you can see that all the security association attribution and DH nuns in a single message in message 1. IK phase 1 aggressive mode, message 2. The responder now has everything it needs to generate DH set keys and send some nuns to the initiator, so it can also calculate the DH set key. It also calculate a hash that is used for the authentication. So second message is a responder responds to the initiator. This is the response from responder to initiator. This is the last message in aggressive mode, IK phase 1. So both pairs have everything they need, and the last message from the initiator is hash that used for the authentication. Our IK phase 1 tunnel is now up and running, and we are ready to continue with the IK phase 2. So you can see that the last message of aggressive mode, IK phase 2 quick mode, message 1. We have already discussed regarding the IK phase 2. In IK phase 2 it's used to protect a user data. So you can see that the message 1, it's from initiator to responder to protect using data protected using a encryption algorithm. You can see the message 2 as well as from the responder to sender. It's also encrypted, same as the third message. So you can see that the IK phase 2 quick mode. So here we can say that IK phase 2 has completed. We are finally ready to protect some user data. Let's see how this is done. IK version 2 does not have any main or aggressive mode for phase 1, and there is a no quick mode in IK phase 2. We have discussed this is the IK phase 1 or phase 2 related to IK version 1. It still has two phase 2. Phase 1 is called IK as a initiator, and IK second one is IK authentication. So this is the two phase used in IK version 2. Only 4 messages are required to enter exchange. Best practice to configure IPsec. So first, use IPsec to provide integrity in addition to encryption. So use a ESP option. Second, use a strong encryption algorithm 3-dash and AES instead of dash. Third, use a SHA instead of MD5 as a hashing algorithm. Fourth, reduce the lifetime of security association essay time by enabling perfect forward secrecy (PFS). Increase the process burden. So do this is only for if the data is highly sensitive. In this video, we are going to discuss the difference between policy-based VPN or route-based VPN. So let's start with the route-based VPN. So in route-based VPN, we have to create a virtual interface. Whatever the traffic hits that interface is encrypted and decrypted according to phase 1 and phase 2 IPsec settings. It's a more flexible, more powerful, and recommended over policy-based. To create a redundant VPN connection and firewall is in route or net mode. 99% of time we have to use route based VPN. It's require a static route for a route based VPN. Now policy based VPN. Tunnel is specially within the policy itself in action of IPsec. At least one policy required. So if route-based VPN is created with two policy, one for inbound and another for outbound, with a normal accept action. When in policy-based VPN, we have required only one policy itself. In this video, we are going to discuss firewall penetration testing, steps, methods, and tools. So let's start with the firewall. We have created separate firewall training course, so you can check out my YouTube playlist. So firewall is the first lines of defense in preventing cyber attacks in every organization. So this is the an opportunity for penetration tester that threat actors alike to attempt the exploit that would be a compromise on network security. So let's start with the firewall penetration process. So firewall penetration testing is the process of locating, investigate, and penetrating a certain firewall in order to reach the internal trusted network of certain system. So most considered to the key part of in external network penetration testing. Firewall penetration testing is the one of the most important type of network penetration test that can be conducted at firewall. Represent the first line of defense against the outside step to perform a firewall penetration test. So there are 8 steps to perform firewall penetration testing, which include the locating the firewall, conducting the trace route, scanning ports, banner grabbing, firewall enumeration, testing the firewall policy, firewalking its Kali Linux tool, and the last one is the identify the firewall vulnerability. Firewall penetration testing tools. So most important tools need for firewall penetration testing are scanner, including Nmap. We can use a telnet, traceroute, HP3, HPing3, and firewall network auditing tool. Step 1, locating the firewall. So every firewall penetration test will be beginning with the locating the firewall. So using any packet craft software like HPing3, and map, the tester craft specific IP packets containing UDP, TCP, or ICMP payloads. So depending on the level of aggression of the scan one wish to perform, HP3 is better choice to avoid abnormal activity from being detected. Let's start with the locating the firewall. So we have to identify our firewall IP address and uh, where it is located. So let's start with the HP3 HPing3. So this is the tool we can find in Kali Linux, and we can do using the command also sudo for the admin rights, hpin3 tool -t for trace route, -1 for the against the target, and here we target one website like firewalldemo.com. Okay, and just enter. So after that you will identify the all the routes for the to reach the website. So so we can identify our firewall. So this is the my VMware IP address, and this is the my gateway IP address. So this is the my firewall IP address, and after that it's redirect to my ISP, and after that it's able to reach the website IP address. So this is our practical lab for locating the firewall, how we can identify the firewall IP address, and you can check it out. Step 2, conducting the trace route. Network range can be identified the running a trace route commands against the firewall located in previous step. This step will also provide the information regarding the routing path of the packets. So it whenever you use the trace route command, so it's identify the routes of route the packet between system or and determine the all the routers or all the network device that are involved in the connection of establishing the process. So additionally, certain information we can penetrate to the device to filter the traffic, and protocol used can be also obtained using a trace route. So in Linux system we are using a trace route, for example google.com. In Windows system it's use a traceat command with for example traceat google.com. Here is the we can identify the uh, our firewall IP or gateway IP using a trace route command. Let's do the practical for the same. Now conducting the trace route. So network range can be identified by running the traceat commands against the particular website and by any particular IP address or any network device. So this step will provide the information regarding the route packets take up between the system to determine all the router or network device are involved in the connection to establishing the process. So for example, for Windows we are using a traceat command, and in Linux trace route command. Right now we are checking with the traceat command. uh, Windows system, this is the one website demo.com. So let's just a minute. Firewall demo.com. So it's the tracing route to a particular hosted platform and IP address. And this is our network gateway IP address of our firewall. This is the my WAN IP address. This is the native IP address, and it's all it's involved all the network device or all the routers which are involved in the establishing the connection. So now traceat is complete. To reach the particular our website, we have 10 hops between the our system IP address, system to destination. So this is all the devices are involved in to establish a connection for the process. This is the third step in firewall penetration testing methodology. Is a port scanning. The most commonly used tool is Nmap for the penetration testing. So in this step, not only not only we identify the open ports on the firewall, but also identify the corresponding service that are running on the open ports using Nmap. So for example, Nmap -ss -p. Uh, uh, we have mentioned the well-known port range from 0 to 1025 and firewall IP and -t4. So here is the we can use a SYN flag and -p for port range and -t for speed of scanning. After mapping all necessary ports and determining that once that port are in open state, the penetration tester can run another nmap scan on the ports to determine which service are running, and running the following nmap scan will be provide the information. You can use the nmap -sv firewall IP and -t1. So after crafting and running the different nmap scan, the penetration tester will have a basic overview of firewall and open ports and service running on those ports using a second command. So let's do the practical for the same. Now step 3, port scanning. So for the port scanning, we can do it from the LAN zone and also WAN zone, but right now we are doing from the LAN zone. So sudo admin rights nmap -s SYN flag -p for port numbers to 1024. We are right now scanning only well-known ports and firewall IP address 0.1 and -t for scanning speed. Password of admin. So it's starting the nmap process. Just wait for the few minutes. Now process is finished. So we can identify the nmap scan report for a particular IP. So it's our firewall IP host is up. This is our latency, and 1021 port filter ports means it's blocked by the firewall. So whenever we are accessing from LAN to WAN or any other zone, these ports it's by default blocked. Open ports is 22 open as state is open SSH 80 TCP open HTTP 443 open, and it's a HTTPS protocol service. So here we are doing scanning from the LAN zone. You can do it from the WAN also to identify. Step 4, banner grabbing. Performing the banner grabbing on firewall will provide the information on the version of firewall. This information can be later used to find the vulnerability of particular version, so we can exploit that. So we can find most in Google hacking database. This is the method for the banner grabbing process. We can use nmap tool call command and telnet and netcat and the military it's a Kali Linux tool. So we can easily we can do the process for a banner grabbing firewall. So let's do the practical with the telnet and nmap. Now we can do the banner grabbing process for the firewall. So sudo for the admin rights nmap -s we we are using a nmap script here for banner grabbing. You can use your telnet as well as, so you need to telnet particular that IP and port number, so you can grab the banner of firewall Right now we are using nmap, so you can do it from the telnet also 0.1. So here is we are using our firewall IP address, so let's enter root password. Now it's starting the nmap process. Just wait for the some time. Now process is finished, so we can identify the 997 ports are filters. uh, Port 22 TCP, it's open, and service SSH version is open SSH 7.4. So we can identify, and protocol 2.0. So we can identify that version in Google uh, hacking database. If is there any vulnerability related to the open SSH 7.4, and so we can identify is there any vulnerability regarding that particular version. So this is the SSH 2.0 open SSH 7.4. Port 80 is working HTTP Apache. So HTTP server header is Apache, and port is 443 TCP. Open SSL HTTP means HTTPS. It's also Apache. So this is the service detection performed by Nmap against the firewall for banner grabbing process. Step 5, firewall enumeration. So every firewall have configured some policy rule set. So in order to determine the with traffic to allow or deny from the internal network, the only indicator of penetration tester can observe while enumerating to access the control base or firewall rule set of the ports on the firewall. So Nmap can be used for the firewall enumeration technique. So let's start with the command nmap -sa firewall IP and -t3. 192.168.0.1 is my firewall IP. So -sa means sign the acknowledgement flag, and -t3 is the speed of the type scanning. So here is the nmap will send the packet to the first well-known port 1025 ports with the acknowledgement flag raised. The return traffic results that indicate that is firewall is open, filter or unfiltered. So if the port is open state, so it's indicate the listening mode. If the state of port is filtered, then it's blocked by the firewall. Finally, if the port is unfiltered state, so we can say that the traffic is passing through the firewall. Means firewall is the passing the traffic through the port, but the port is not open. So let's do with the practical. Now let's we can do the banner grabbing process for the firewall. So sudo for the admin rights and hyphen s v script. We are using a nmap script here for banner grabbing. You can use telnet as well as, so you need to telnet particular that IP and port number, so you can uh, grab the banner of firewall. Right now we are using nmap, so you can do it from the telnet also 0.1. So here is we are using our firewall IP address, so let's enter root password. Now it's starting the nmap process. Just wait for the some time. Now process is finished, so we can identify the 997 ports are filters. uh, Port 22 TCP, it's open, and service SSH version is open SSH 7.4. So we can identify, and protocol 2.0. So we can identify that version in Google uh, hacking database. If is there any vulnerability related to the open SSH 7.4, and so we can identify is there any vulnerability regarding that particular version. So this is the SSH 2.0 open SSH 7.4 port 80 is working HTTP Apache. So HTTP server header is Apache and port is 443 TCP. Uh, Open SSL HTTP means HTTPS. It's also Apache. So this is the service detection performed by Nmap against the firewall for bandwidth grabbing process. Step 6, testing the firewall policy. So in step 6, we are test the firewall rule set, test the web filter policy. So there are two methods to test the firewall policy. You can test with the firewall policy like source IP, source port, destination IP, destination port, and you can test uh, also zone based that you wish to test that. And using a test a web filter policy. So web policy that you wish to test, you can include other parameter like particular URL and particular authenticated user or on particular time or on particular day. So we can test the firewall policy in step 6. Step 7, firewalking. So firewalking is the tool and method of mapping the network device that sit behind the firewall. The firewall network auditing tool analyze the packet written by the firewall with the use of traceroute techniques. So it will determine the open ports on firewall by checking the device behind the firewall and identify which traffic is able to pass the firewall. So the firewall tool is considering to perform advanced network mapping. So it's able to paint a picture of network topology. Here is the we can see the one uh, graphical so for the firewalking. So most especially by crafting the packets with certain TTL value, the penetration test can be identified the open ports if the written message is received with the exit TLL. If no response is received, it can be concluded that the firewall filter the packet and block the connection. We are using a firewall Kali Linux tool. Uh, so let's do the practical. Now let's discuss the firewall tool in Kali Linux. We have already discussed regarding the firewall tool. It's active recon network security tool. For you need to first download from the GitLab and you can clone that particularly GitHub directory, or you can install using as a one simple command apt install firewall. Sudo is for the root access. So after that I have installed using a command. Then I am able to find the firewall keys here, password, and in firewall uh, option target gateway metric and -d for a destination port, -h for help, -i for interface, -n for do not resolve IP address into host name, -p for particular protocol TCP or UDP, -r for restrict the RFC, and you can scan the particular port range, and you can also mention the particular source port, and T1 for the packet readout time, small t1 for the IP time to leave, V for program version, and -x for the expire vector. So I have proceed the particular command. So here is the command sudo firewall -d is for destination port 543, and you can mention 80443 which port you uh, want to scans again the firewall tool I for interface. So this is the my our VM lab interface. So I have mentioned that it is 0 -n for do not resolve the IP to hostname -p TCP protocol This is the my system IP address, VM system IP address, and this is the target of particular global DNS IP. So I have it's proceed for the TTL1 to TTL25, and you can able to see the response if is any we will get the response. Right now it's no response because I have mentioned the port 543. So you can identify the total packet sent, total packet error, total packet caught, and total port scan and open and unknown. So if you have mentioned any port range, and then you are able to particular find the particular port range. So for example, we are doing for the port against the IP address in a firewall. Let's see what happened. 0.1. Capital S for the port range. Here is the port range is uh, particular. We are find the particular regarding the 543 port. Let's scan. So it's a TCP based scan because we have used the protocol TCP. Wrapping the phase source port 543 and destination port uh, 3343 because we have used the source ports. Just check with the destination port 1D because 543 port is open at our firewall end. So just wait for the some time. So it will check by the particular T1 by checking the TTL value. Here we can set the scan abroad hop count exceed. So total packets and total packet errors, codes. For example, here is a firewall. This is the source port range. Hyphen is Ethernet 0 hyphen N is do not resolve the IP address hyphen P protocol. This is the uh, IP address of system, and this is the target IP address. So firewall gateway receive scanner. So it TCP based scan and TTL1 expired in 192.168 1.1 binding host scan bound to hops support it's no response 80 is open 8081 is no response so total packets and 4 total packet code 2 code of interest and scan and open port it's all about the firewall tool. Step 8 identify the firewall vulnerability. So first off, we have to disabling the service that we are not needed and checking the firewall configuration is the only way to ensure the safety. If we are not using any service, so make sure it's disable at firewall end. So we can secure the networks. And for finding the firewall vulnerability, we can visit the website uh, cvedetails.com. So in that website we can find the particular vendor based firewall vulnerability and particular the version based the vulnerability. So that's in this website we can able to find the if any present vulnerability is available for particular version, so we can patch that particular vulnerability. Yeah. So you can identify the firewall vulnerability by vendor or by product. So let's visit for the website cvedetails.com. Step 8 identify the firewall vulnerability. So first off, we have to disabling the service that we are not needed, and checking the firewall configuration is the only way to ensure the safety. If we are not using any service, so must sure it's disable at firewall end, so we can secure the networks. And for finding the firewall vulnerability, we can visit the website cvedetails.com. So in that website we can find the particular vendor based firewall vulnerability, and particular the version based the vulnerability. So that's in this website we can able to find the if any present vulnerability is available for particular version, so we can patch that particular vulnerability. Yeah. So you can identify the firewall vulnerability by vendor or by product. So let's visit for the website cvdetails.com. Let's visit for the CVE details website. You can identify the particular products base and vulnerability by date, search vulnerability, and you can identify the particular CVS code distribution. So just checking with the CVE details. For example, you can search here particular firewall. So you can get the many vulnerabilities regarding the any product related to firewall. So in Indian firewall checkpoint, this is the also for the filescape personal firewall, Barracuda. So you can identify any product related, any firewall product related the vulnerability if you search the particular in firewall. So you can also search by vendor. For example, here vendor search, we can search cyber. So we can get the cyber related particular vulnerabilities. Here wise one number of vulnerabilities and code execution, and you can check it out for the any product. For example, now let's check with the Sophos. You can identify the Sophos related all the vulnerabilities. Palo Alto. So you can identify the vulnerabilities regarding the Palo Alto. Just check it out with your vendor, which is you are using a firewall checkpoint. Sorry, spelling mistake. So it's all about the vulnerabilities regarding the checkpoint. So you need to check the vulnerabilities and particular on which version is available. So if is there any patches available to uh, uh, overcome this vulnerability. So you can patch the particular vulnerability, or you can upgrade your firewall with the minimum vulnerabilities is available in that particular firmware. So it's all about the how to we can identify the vulnerabilities of any firewall.